Hi guys, I'm Bobsy, and in this video we're going to continue off from our previous inventory tutorial. People have really seem to like this longer video format where I explain a little more, so we're going to continue in that direction. Now in this video we're going to go a little bit more in depth with one of the things that I stated in the previous one, which was that this is a very scalable system, because it was questioned in the Discord server of PurrNet, which is completely fair, but it was questioned whether this system was actually properly scalable or not, because well, a lot of things seemed, quite closed, and a lot of things didn't really seem to scale very well with, custom cases. So let's set up a custom case, right? Because the example that was mentioned was, let's say that you have a weapon and you want various attachments on this weapon. Well, how do you now, modify an item in the world? And then when you put it in the inventory, it'll just become the same old item because we are relying on the preset, right? Which will always just hold the standard prefab. And that's completely valid, but there's plenty of ways to go about this. One of the reasons why I set up the system as I did is because it's very bare bones and it's very split up. It might look like the item script itself is sort of a very redundant script, right? Because it doesn't really do much, it just points back at the preset. And that's fair, but the point of it is that now we have a base to build off of, and I think this is exactly how we should see it as well. So what I want to do now is I want to start for us to expand this a little bit so we can have custom items as well with custom data, and they can really act however you want it. You're able to set the data that they have, you're able to initialize them how you want to initialize them, and you're able to store the data how you want to store it. This is one of the ways that we can really show exactly how much this system can actually scale. So if we start by doing that, I'm going to start by heading into our item script, and then we're going to make an interface in here. So it's going to be public interface, and I'm just going to call this custom item, for example. Now we have a custom item interface, which we can use for any items that needs to, well, be custom. And we need to define what do we want to do here. And I think the only thing we should be able to do is the set custom data. And we're going to have some kind of data type in the set custom data. And now what I've chosen to do is I've chosen to go with a byte array. And there's many ways of going about it. There's many ways that we can read and write data and so on. But I found that I think for this setup right now, instead of going the generic route, which is also by no means bad, I think we can keep the system smaller and more compact by just going for a byte array direction. And all we need to do is just be able to read and write our data to and from byte arrays. And the thing is, because we want custom data structures, right? We might want one item holding custom weapon data. Then we want another item holding custom armor data, or another one holding custom magic data, or whatever that you want to hold. And therefore we sort of on a per item basis can choose how we want to read and write the data instead, which is why I wanted to go for the byte array direction. Okay, so going with this, let's quickly go and make a custom item. So if I just go out here and make a new script, and I'm just going to call this one my custom item. You can call it whatever you want. This is going to be your item. So this is going to be your weapon. It's going to be your whatever. In my case, I'm just going to call it custom item because, well, I just want, for it to be very obvious what we're working on right now. And what we're going to do is this is going to inherit from item, but it's also going to inherit from custom item. And now you'll see it has an error, and that's because it obviously wants us to implement the interface member, which is the set custom data class. And this is where we'd handle what actually happens with that custom data. Now, going from here, let's try and think about how we actually pick up, right? So going into the player clicker, what happens is, right now in my case, I click on something and it tries to add it to the inventory. And the thing is, the inventory now needs to hold some kind of custom data for the item, right? So we already have this struct, which is called our inventory item. And I think this is a good place for us to just hold this byte array, which is going to be our custom data. So now the inventory item can hold it, but it's not yet populated. It's not used for anything. Now let's go up a little bit. And as you can see, the try-add item is the method that we always use to add items. And I think this is also where we should send through the custom data. So let's just add the byte array for custom data, and let's just have it default to null. That way we don't break anything existing really. The only thing we do break is the shared inventory. So if we just quickly go in there and just add it to the end of the triad item here as well, we should be all good to go. Now going back, to the inventory, we also now want, and I'm going to do it without the null, also want it to the try stack and to the add new item here. The reason for that is obviously we need to be able to send the custom data through, and there's a bit of a different reason for both of them, and we're going to get into both of them in a little bit. So just firstly, the try add new item, this is obviously when a new inventory item is created from scratch, and this is essentially just where we want to store the data. So it's really going to be as simple as that. We're just going to do inventory item dot custom data equals to custom data. So even in the case of it being null, it doesn't matter. We're just setting a null to a null, and that doesn't really change anything. So that all works. And then we also want to be able to compare, for the stacking. So we want to check, whether we should stack, and therefore we want to be able to compare. And there's actually an easy way to do that. So let's go into our inventory data utilities here, and let's make a new public static pool. And we can, for example, just call this our bytes equal. And what we want here is we want to be able to send through both our byte arrays. So we're just going to call it byte array A and byte array B, like that. So here we have them. The first thing we want to check is just, are both of them null? So if A equals to null and B equals to null, well, then we just want to return true because, well, you know, they're both null, which means they're the same, which means they can stack, right? Now, if we say that only one of them is null, so if A equals to null or B equals to null, that means only one of them is null, which means in that case we want to return false, because one is null, one is not, meaning, you know, one has data, one does not have data, and they're not the same. And then the last thing we can also just do as a little performance check is we can just check the length, essentially just checking if they are not the same length, they can't be the same data. So in this case, we also want to return false. And then once we've gone here, we now want to for each through it. And we essentially just want to for each through one of them and just check is everything that's in there the same, right? So if we're checking if A at position I does not equal to B at position I, that also means we can safely return false because they're not going to be the same. And then if we get through all of this, we can return true. We can actually make it even shorter like this. There we go. Now this is just packed neatly into our bytes equal. This is our little static comparison. And if we jump back now into our inventory script here, where we try and stack, we can now also check here where we have our previous null check. We just check here and say if we do not have, if it is not inventory data utils dot our bytes equal. And then here we send our inventory item dot custom data, and we send our custom data that we just came in with. So now we have an easy point of comparison as well. And that essentially now means that now the inventory is actually set up and should already be working with stacking of custom items. All right, cool. So that's a really good start. And also one thing that's important to mention is one of the reasons for us using a byte array as well is that, well, byte arrays can easily be sent over the network with PurrNet. Okay, cool. Now going back to where we actually add the item to the inventory, so back into the player clicker, you can see we have the triad item, but now we need to, you know, feed it in case there is custom data. Now the thing is, our item itself doesn't actually hold necessarily any custom data. We don't know that at this point, right? Because it doesn't hold, the item script itself doesn't actually hold any custom data. It would just be if it's an iCustom item, so we could check for the interface and then search for it or whatnot. But what I actually think is cleaner to do is just have the item itself added to its correct inventory. So if we add a public virtual async task, that returns a bool. Now the reason for this is because in our inventory, this is a public virtual async task. So, you know, we need it to be awaitable. That's very important because in the player clicker, we obviously await for it and search for it here. So what we want to do now is we want to be able to have an add to inventory in the item itself. Add to inventory. And the reason why we make it virtual is so we can override it in our custom item and, you know, send custom data. So here we just send the preset. Oh, sorry, this needs to be, as input, we need the inventory. That, of course, we want to be added to. And then we can do inventory dot triad item. And this is where we feed it our preset and just the quantity we want to add. In this case, we just want to add 1. And then we can just return a wait for the triad item. And there we go. So now this works. And now in the player clicker, what we want to do instead of doing the inventory triad item, what we do is we get the item and do add to inventory. And then we just feed it the inventory that we have, which is underscore inventory. There we go. And there we go. So now it's adding itself, the item is essentially adding itself to the correct inventory. It's essentially just being told, hey, add yourself to this inventory, and then it will. And what we can do with this is, because it's virtual, we can go into our custom item and we can override the add to inventory. So I'm going to override the add to inventory here. And this is now where we can then choose to feed it our custom data. So instead of just returning the base here, I'm going to go back to my item. I'm just going to copy what we have here because it's going to do pretty much the same thing, but not exactly. And then here, when we add it to the inventory, we essentially want to pack the data and then send it through. Oh, and I of course need to mark that with async. That's why. All right, cool. Now let's make the data that we actually want to use. So let me make just a private struct, and I'm just going to call this my custom data. And this can hold whatever we want. One of the things I do want it to hold is a color, just so we can visibly see it. So this is just going to be called color. We can also hold whatever we want. We can hold a string. That's just going to be my string, for example. And, you know, you can put whatever data you want in here, essentially. And this is also where you could put the data for what attachments your weapon have, if that's the case that you're going for, right? And of course, we need to be able to hold the data. And actually, I want to be able to do system.serializable, just so we can serialize it and we can actually see the data in Inspector. I think that's a little better. Let's do serialize field, private, custom data, and we call this custom data. And then let's also just have a reference to our sprite renderer, just so we can change the color. Now that we have this, all we need now is a way to pack our data into a byte array, and also pack it from a byte array back to our data. let's get to that. And in that, I want to do it in the inventory data utils again. And what we're going to do is we're going to let me make a public static, and this will return the type of byte array, which will be pack custom data. We need to, of course, feed it the type that we want to pack, and then we want to feed it essentially the data, and T has to be a struct in our case, because it's a struct data that we want to pack. All right, cool. So the way that we do this is, and this is where it gets a little bit more advanced, and I'll try and go through, but essentially we'll be utilizing the bit packer of PurrNet, which packs things quite efficiently. So I'm going to be using var packer equals to new bit packer. So here we have a packer for us. And essentially I'm going to say packer with type T has to write to this packer with this data. With this, we can now get it out as the bytes. We can do a new byte array that has the length of the packer.length. And then right now, the thing is the bit packer will default to a certain initial size of 1024. And luckily, Microsoft actually already has a built-in way for us to handle this with the system buffer. So what we're going to do is we're going to do system.buffer.block copy. And what this will essentially do is right now your bits can have a whole bunch of data in here. And it'll also have a lot of filler data by the end of it, because it's trying to be the correct length. I hope that makes a little bit of sense. And what we're essentially doing is we're just trying to take out that filler data. So we're going to do packer.buffer and then just 0 offset, and it's gonna output it to our bytes, and we're going to give it the packer.length as well here as for the count. Now we essentially should have a clean byte array, and we should be able to just return the bytes. Like so. I know this might be a little more advanced, but really this is all we have to do, and we can now pack data. So, and you essentially never have to look at this again. This is why I'm a little okay with skipping over it quickly. Hello, frienderinos, Bobsy from the future here. I just really quickly want to say this can be made more efficient. Right now we're allocating a new bit packer each time, and that's even though we are disposing it because we're using here. We're still essentially expanding the bit packer pool that we have constantly, which we don't want. And for that, all we want to do is just use a bit packer from the pool instead, because we have packer pooling in PurrNet. So what we've got to do is we've got to do bit packer pool.get, and that's really it. That's all you have to do here. Just letting you know that this is a lot more efficient. Do this instead. Now we want to, of course, return back the type. So we want to do unpack custom data with our type. And this is, of course, going to take in a byte array for our data, where the T is once again a struct, just so we can make sure that we're moving from a struct to a struct. All right, cool. Very first thing, of course, is we want to check that the data just isn't null. If it is, we just want to return defaults. And another thing we might as well also check, we want to check or if the data.length is just 0, same thing, we just want to return default. There's no point in doing any more operations here. And now once again, we're going to be using another packer. So we're going to be using our packer. We're going to make a new bit packer here. And now we can grab the packer and we can say make wrapper to a new byte array, or byte data, sorry, which is a data type. And that needs to be a new byte data. There we go. Out for the data. And now we can get the result. And first of all, we have to just cast the result to something, which in our case, we're just going to cast it to our data type, or the default version of our data type, whatever it is. Now here where we have the result, we can now read this from our packer. So what we're going to do is we're going to do packer with type T dot read. We're going to read from the packer, and we're going to reference it out to our result, and then we can just return the result. There we go. So now we've read it. So essentially all we do is we grab the bit packer, we make the wrapper for the data. We now get the result, or we essentially make, I guess, an empty result, you can call it, or a default result. We read it and we return it. So now we essentially have our two packing methods here. Hey, again, you're not going to believe this. Funny thing happened. We of course got to do the bit packer pool here as well in the unpacking of the data. And even better, when you do get the bit packer, you can actually automatically just make the wrapper by just taking the data that we're using to make the wrapper and just putting it directly inside get. And that way we don't even need this line. So it actually got even shorter and once again, a lot more efficient. So do this instead. And we can now go back into our custom data, which is where we need to do it. So for example, in our case where we want our data back, so set custom data is when we want to, essentially set it again. What we can do is we can do underscore custom data equals to inventory data utils dot unpack custom data. We want to pack it to the type of custom data, and we want to feed it the data that's been input. And there we go. Now we have our custom data, and then we can also just, for good measure, set our color. So sprite render.color equals to custom data dot color. There we go. So now we should have read the data, and we set the color again. That should hopefully be simple enough. And same when it comes to adding to inventory. Let's do var data equals to inventory data utils dot pack custom data, and we're going to feed it our custom data like so, and we're going to just put that custom data right in here. Okay, cool. So let's try and see if this works. I hope I did not forget anything. I think we added to the inventory correctly, shared inventory. I think we hopefully should have everything now. Let's try and go and see how this works. So now I guess let's go and set up a custom data item as well. So let me just go make a 2D object, sprite. I'm just going to make it a square. And I'm just going to call this custom item. And we can make this into... Actually, we can just keep it a white square. It doesn't actually matter much. Now let's give it the custom item script. This is of course where you'd give it your weapon script or whatever you would want to give it. We need to feed it its own sprite renderer. We can set the custom data. Let me just start by setting it to white. We can make some variations. And the string here can be PurrNet rules, for example. All right, cool. We have our custom item. We can also go to our resources folder here, make a new scriptable item preset. This will just be our custom item preset, for example. And oh yeah, we of course need to feed it an icon. I think just we don't actually have this. I guess let's give it some custom just so we can easily identify it. So let me give it this one, tile 0000. So in here I'm gonna do the same thing, tile 000. And then in the custom item, I'm gonna give it the preset. Here we go. And then I'm gonna make a prefab out of it. Custom item in here. And then in our custom item preset, I'm gonna drag the custom item object in here. I'm just going to call it custom item. Again, we don't actually use the name for anything. But here we go. So now we have our custom item. Let me just make it bigger. And let me also make sure to give it a box collider 2D so I can actually click it. All right, cool. Let me just take all our wood out here as well. I don't want that right now. And now let's just, first of all, test that it even works as a normal item. So I've put a bunch of them and you can see I can click them. I can stack them. I can move them over. I can drop them again. Oh, actually, I forgot to scale to apply to the prefab. Hopefully this should work properly now. We can pick them up, we drop them, yeah, they're the right size. When we move them back and forth, as you can see, that works too. Looks like something's odd with the data here, but we can look into that in a little bit. Let's try to see, so they do stack here. Okay, so let's start by just focusing on our local player inventory, and then we figure out what's happening with the shared one in a little bit. Okay, cool. So now that we have this, let's try and set them up with some different data as well. So let's make this one, for example, red. And this one's gonna be hello there, whatever. And this one is gonna be blue. And then this one is going to be like and comment. Okay, cool. Now that we have this, I'm of course going to make this one blue as well. There we go. So now we have them. As you can see, I can pick them up and I can pick this other one up and they now don't stack. And as I drop them, oh, they didn't initialize. Because why actually did they not initialize? Are we forgetting? Oh, we're probably forgetting to set the custom data here again. So let's just go and do that. So in the inventory, I completely forgot about that. We want to do with the spawn item here. While we actually spawn the item, we instead want to send the full inventory item because we need a little bit more information now. Now let's go back to where this is called and just make sure we just send the whole inventory item. Now what we want to spawn is just the inv item.preset.prefab. And I'm just going to call this var spawned item like so. And then we're going to do if item.custom, not that, sorry, if in item.custom data does not equal to null. We can pretty much safely assume that it is a type of custom data, but we can also do it spawned item is a custom item. And when we just name it custom item, for example, then we can do custom item dot set custom data. And then we of course have to set it to the end.custom data like so. There we go. So I actually forgot to set it when we do spawn it. Now bear in mind, this right now is not networked and we'll get into that a little bit. But right now we're just setting it as we put it down. So now let me try and pick it up, pick that up, and drop that, drop that, drop that. There you go. Now you can see it actually works and it correctly initialize them again. And of course also if we just go and look there, you can see this one's hello there. I pick it up, drop it again, still hello there. This one was like and comment. This one's PurrNet rules, right? Cool, so that works. Let me see, does this just work? No, that obviously does not work. Okay, so we need to figure out how we handle that as well. But okay, cool, that's a good start. And now we actually have that working. But let me also just quickly try and open up a clone. One thing I quickly realized was in the shared inventory, we're not actually sending the custom data in here. And the tried item, so let's just quickly go and try that to see if that just fixes the issue where it actually does not. No, it doesn't look. It still resets them. Okay, we'll need to figure out why that happens. I haven't tested this at all. Okay, so now I'm gonna pick something up on the clone and I'm gonna drop it again. And now you see it didn't come out with this data. This is because right now we're doing absolutely nothing to actually network the actual custom data. Now there's many ways you can go about this. One of the easiest ways will very likely be to just sync var the custom data. That's one way to go about it at least, and then actually utilize the sync var instead. So can do that, and I don't think that's a bad idea. I'm just going to do it in my case. Or Alternatively, again, because these are all serializable, or we can just send them over the network, actually. Might not be a half bad idea. I don't think that's a bad idea, actually. Let's try and do an observers RPC with buffer last true. Just to see this, obviously, with the unsafe network rules, which allows clients to call this. Just so you're aware. But I actually think this might just work. Now let me just try and drag this guy over here. Drop my hand to drop him, and you can see he actually initializes with his data. So that's actually an easy way to go about it. Yeah, so that's an easy way of going about syncing that. Because it is just a full byte array, meaning we can easily just send it over the network, and then they locally will just unpack it as needed. The next thing that we want to figure out, let me also just make this a little prettier. The next thing that we want to figure out is why the shared inventory doesn't actually work. So let's try and, I guess, just follow the logic from the beginning, right? So we click on it and we click add to inventory, to this inventory. It's then being sent to this inventory. It should then be added to this inventory with the custom data, meaning the server here should receive it with the custom data. I guess we might as well just log that out real quick just to test it. Not logger. I don't know why it started doing that. Let's just say it has custom data. Let's just test that real quick. Just make sure that it actually receives some custom data. It does not. Interesting. Let's check the stack trace. So it comes, well, it goes through all the network. I guess we can't really go behind. That's because we're not adding it from the inventory there. We're clicking on the item. I'm silly. It's me being a goofball right now. I completely forgot how the system worked. Going back in here, let's just go to, what did we call it? Inventory tile, I think. And then when you click on it, we say inventory view interact here, which goes to the inventory interact, which is being overridden by the player inventory here, which then tries adds the item here, which should then be inventory items at index.customData. There we go. That should now actually add it properly, I think. So now let's go and test that. I hope that makes sense. Let me just go over very quickly. It was here in the player inventory. While when we interact with the tile, we need to of course send the custom data with that click. And actually we will need to do the exact same thing in the shared inventory interact. So let me scroll down, go to shared inventory interact. Here we of course need to send the data with it as well. So we send it back and forth. Now let's go and test this real quick. Oh, what did I miss? Is it just one too many? So now let me try and play here, pick it up, send it over, send it back, drop it. There we go, still blue. Now let me go and try with the client here as well, and just make sure that we can actually send it back and forth how we'd want to. So my client connects, here he is, he's gonna pick it up, move it over. This guy can take it out, drop it, there we go, still blue. So as you can see, now we're actually moving custom items around. So we can pick them up, we can send them all over, here we go. And when we drop them, they're all seen as individuals. And also notice how they're automatically just seen as individual here when we take them out. They don't stack as well. And yeah, everything works pretty cleanly. And now we have custom data and they initialize properly into the world. So that was actually surprisingly easy to get fixed. Sorry, I didn't come a little more prepared. I completely forgot about the shared inventory as a part of it, because I just assumed mostly would work, and it mostly did, to be fair. So yeah, this is pretty much how I would do it, and I hope you see now how this system is very scalable. Now we can all of a sudden also handle custom data very easily. And again, I know what you might be thinking next is, well, we're not rendering them in the inventory. And well, you can just do that. Nothing is stopping you from actually doing the same thing as we're doing for the world item right now, where essentially we have the item and then we can also have a custom item. You can do the exact same thing for essentially, you know, inventory view or whatever. Like, you know, when this initializes it could take the custom data or something like that, right? It could be the preset that would likely hold then information as to, you know, either what type it is to, you know, read and write it as, or something like a custom tile, right? So instead of initializing just this generic tile, it would take something that inherits from tile, but then can utilize the custom data, unpack it correctly, draw it correctly in here. So that way you can also have the colors and whatever you want initialized in here. So cool. I hope that makes sense. I hope you like these videos that go a little bit heavier, a little bit more in depth, and a little bit more explaining. But hopefully out of it, you should also get something very valuable, which is essentially systems that come out a whole lot more scalable, because it allows for, you know, custom items, custom interactions, and so on. So always remember PurrNet rules. Remember to join our Discord. Remember to like and comment and subscribe. And other than that, I just hope you have a wonderful day.